Well, gentlemen, thank you all for joining us for this panel discussion and an opportunity to really dig in a little bit to the nature of space, the criticality of space, the value of space as part of our overall national infrastructure and as a really key engine of growth in the broader economy. We've got a really interesting panel here that has folks that come at this topic area from a variety of different perspectives. So we're gonna hear from folks who have lived their career focused on space launch, focused on applications from space, but also focused on the application of space in the terrestrial environment. It's a great opportunity, I think, to pull all of the pieces together. My colleague who published a paper on the value of space that was presented a little earlier in the conference, I don't think they were thinking about it in precisely these terms when they wrote it, but when I went back and looked at their paper, I noticed the word critical shows up in there 7 times. So while we don't expressly define space as a critical infrastructure, and indeed space is not an infrastructure in the classic sense, its interplay with many other areas of critical infrastructure and many functions in society that are broadly understood as critical to well-being is pretty impressive. The emergency services applications are just one of many examples. What I'd like to do in the conversation we're having here today is really make sense of the critical ways in which space plays. And I'd go from the downstream applications all the way up to the critical enabling factors for launching and sustaining space capabilities. So hopefully that makes sense to everybody and would be a great opportunity just to have an open conversation about what space is doing. Let me start with Professor Lowenberg de Boer and ask you to talk a little bit. In fact, I'll go around the panel, ask each of you to talk a little bit about how space has played in your own career. We've heard a little bit about your resume, but why on earth are you sitting with us today? And how do you think about the space sector and how it's played in your personal career? I'll start with you, Dr. Lowenberg de Boer, because you've come the longest way to space.
So my whole career has been focused on the economics of agricultural technology, and increasingly in recent years, agricultural technology has depended on space and space infrastructure. And let's take the example, the most successful precision agriculture technology worldwide is GPS guidance. So increasingly agricultural equipment is guided by GPS, either with manual light bar technology or auto steer. And in the future, it will become even more important as we see more and more autonomous equipment. So right now, most of that equipment, even if it has auto steer, it has a manual override, and a human being could run it without much problem. With autonomous equipment, that will become increasingly difficult. The other part of that is remote sensing, and so increasingly agricultural decisions rely on remote sensing data. So that, for instance, nitrogen fertilizer is increasingly dependent on what the remote sensing images tell farmers and agronomists about crop fertilizer. So just very briefly, that's how my career and my work interacts with space infrastructure.
Thank you. Let me turn to Ron. Ron, you've been with Homeland Security and working some really tough problems there. How do you think through the space issues and what brought you to it?
Thank you again for having the opportunity to participate in the panel, and thank you to each of the folks here on the panel with me. Yeah, my background in space started in the Air Force. and I finished there, and then slid over into critical infrastructure and the regulatory side for about 18 years before I joined Homeland Security. Getting back into the space business has been a natural progression as I continue to look at the national critical functions and their interrelationship from a cybersecurity perspective. More and more, we're seeing adversaries impact cybersecurity of more and more sectors. And while space is not a sector per se, the impact of space on every one of the sectors is, there's no doubt about that. And so we're taking a hard look at cybersecurity, mainly from the left of launch, in the manufacturing area, the supply chain area, up to the development of the birds before they go into launch. But we're also working with NASA and U.S. Space Command in terms of working to the right of launch as well when cybersecurity incidents actually happen. And so for us, space is just a natural progression in the risk assessment and risk management arena for all the national critical functions that affect the United States.
Okay, thank you. Frank, you've been working with the Space Development Agency, which is doing some exciting activity and just moving forward with some important demonstration contract awards in the last couple of weeks. How do you make this, how do you think about the criticality of space, and how is it playing out in your current work?
Well, I think one of the things that SDA is really trying to do is we're actually trying to create the space infrastructure for the warfighter. Traditionally, military systems or national systems have been more unique, more one of a kind, with the potential exception of GPS, which, you know, is almost an infrastructure in and of itself, but that may be the only one that really for the warfighter actually exists. And so SDA is trying to change that model. We're literally trying to turn space into a commodity. We're trying to create a marketplace. We approach the way that we are going to build and launch systems not as buying individual satellites or buying an individual constellation, but really creating a marketplace where industry wants to put effort and their own capital and their own creations into that marketplace and turn it into something that enables the warfighter no matter where they are on the planet. So we get in our cars and we drive, and if we're outside of a radio station area, we turn on satellite radio and we listen to it, and we do that anywhere we are. And we're trying to do the same kind of communication model for the warfighter so that they have that ability no matter where they are, and we can get data from point A to point B in the same kind of latency that we see with every other space system, which hasn't existed up until this point. So we're literally trying to create a brand new model.
It's an exciting potentiality, and you guys have been pushing forward really fast. That lets me turn to General Wayne Monteith, who of course, was responsible for trying to enable a whole bunch of launches into space on a very fast tempo to support concepts like the one you're talking about, Frank, but now has a broader safety responsibility with FAA. Wayne, can you talk a little bit about how you think about these issues?
I can. So much like Ron, I cut my teeth on space in the Air Force, and was blessed to have two really unique opportunities over my 29 years. And one was running the 50th Space Wing, which provides GPS to the world. And then the last one was as the commander of the 45th Space Wing and director of the Eastern Range for the last 3 years, running arguably the busiest, most successful spaceport in the world. So when I think about space, you know, I'm taken back to folks that I talk to who aren't in this business, and the analogy I would use is day to day, at any given moment, you probably don't think about oxygen, and you don't think about oxygen until you don't have it. Then all of a sudden, oxygen becomes about the most important thing you can think of. In space, is the same way. So when you're driving down the road and you're looking to get to grandma's house and you've got your navigation device going, it's great. until the navigation device doesn't work. And you don't think about the satellites that provide that. All you care about is you've got a navigation device in your vehicle. And so as we move forward, I believe we have to look at space and space assets, and particularly now, the ability to get to space as a critical asset, because we can't lose what we have on orbit, and we certainly want to continue pushing ahead, whether it's, as Frank said, from a warfighting perspective, or quite frankly, our national economy.
Some big concerns there. Let me stay with you for a second, if I can, Wayne. The FAA, obviously you're in the portion of FAA responsible for space issues specifically, but FAA, the bulk of the agency, is of course focused on terrestrial airspace, and we've got a couple of really big and complex issues related to the interplay between space and airspace, and the interplay between space capabilities and the safety of the aviation writ large. How much visibility do you see in your air-breathing colleagues within FAA to their degree of reliance on space capabilities for safe and efficient operation of the national airspace system? And how worried should people be that if there were failures in space infrastructure areas, that their consumption of safe air travel, for example, once we actually are traveling by air again, which I hope will be happening sometime not too far into the future, how worried should they be that that could be interrupted if there were failures in space capabilities?
I would say exceptionally worried. So to answer the first part of your question, tremendous knowledge and support from the aviation side of the FAA for the work that we're doing, and a keen understanding of how space impacts the national airspace system, both positively and negatively. So I'll touch on the negative real quickly, and that's what we're seeing in our increase in launch cadence. That's going to continue to grow, particularly as we see these proliferated low Earth orbit constellations. In the month of August this year, we supported as many FAA licensed launches as we did in all of 2011 and 2012 in 1 month. We supported 4 launches in under 4 days. That's as many launches as we did in 2012. And so it's growing. We closed out this fiscal year with 31 launches, and we anticipate next year could be going past 40, shortly past 50 launches a year. So there's an impact. So the FAA is keenly concerned with that, keeping the aviation community safe and minimizing disruption. So we're currently going from what we call a segregated environment to an integrated. Right now, we segregate huge swaths of airspace for large periods of time because if there's a mishap in flight of a rocket, it could take anywhere from 14 to 17 minutes to get direction into the flight deck so that they can do manual inputs. The systems we're working on now will take that into less than 1 minute using upgraded IT equipment and taking advantage of things like GPS. Now, when you look at it from the positive side, absolutely, whether it's from communications or again, specifically for GPS. We use GPS today, but one of the systems that the FAA spent over a decade developing was ADS-B, or Automatic Dependent Service Broadcast. And so with ADS-B, we go from having to rely on radars to being able to process that GPS and every single second provide updates to the air traffic control system. So now we can have more efficient air routes. We have more accurate location information from both in transit, quite frankly, and if there is an accident and there's a search and rescue operation that has to go on. But this fundamentally changes the airspace itself and how we manage it. And we even have, while we have, I believe it's over 400 ground stations, in Alaska alone we have 42. And so you don't have to rely on radars, and you don't have a whole lot of radars out there that can get you through the mountainous systems. So again, it's a safe system, but they need it. And not only do we need today's generation of GPS, we need tomorrow's generation as well.
I really like how you pulled together those two parts there. Let me, if I can turn to Ronald for a second. When you're thinking across a broader set of things that are defined as critical infrastructures, how much comes in, how much do we pull into that conversation, the degree to which the infrastructure itself or the things that rely upon the infrastructure would gracefully or gradually degrade, as opposed to, you know, rapidly drop off or catastrophically degrade? Are those conversations that go into that evaluation?
Comes to me.
Yes, right.
Not really. When we're taking a look at cybersecurity and infrastructure, we're taking a look at the impact to that infrastructure from the adversary. We're looking at the risk to that infrastructure, and we're looking at the impact that infrastructure has, both within the industry that it pertains to and across other industries as well. I don't know that we take a look at the degradation of it from the perspective you're looking at, as much as we look at the degradation of it from the impact of the adversary.
Mm-hmm.
Our risk management strategies and our risk assessment strategies tend to look at what happens if something impacts it today, as opposed to what is the impact later down the line. Now, with space systems, the systems you have on orbit right now, the legacy systems, some of those may be in orbit again for another 10, 15 years. And so impacts that happen today could have a 10, 15 year length. We're starting to kind of take a look at that, but with terrestrial infrastructure, I think it's a little bit different perspective.
Okay, that's helpful. As we think about the general concept of protection of critical capabilities, that's intertwined with a measurement or a sense of reliability, right? If something is available 24/7 and, you know, is providing multiple nines of reliability, other actors will essentially tend to take it as a given and can build business plans or operational plans or what have you around it. And I think it's clearly the case today that for something like GPS or weather modeling, that there's huge swaths of the economy that are simply assuming that those will be there in perpetuity. We saw this, you know, we saw in the IT industry and in other industries how having these sort of highly reliable services to which people had consistent and secure access enabled the development of tons of other applications, right? And Jim was talking about this a little bit with agriculture, right? A tractor that is driving itself on the strength of a GPS signal, and maybe is planning its route on the strength of data that's come in from some sort of Earth observation system in some cases, is a system that is sort of a highly tuned application that's assuming a bunch of other stuff is there and works. Are there, to the panel at large, what have you seen as far as those kinds of applications which kind of develop into explosive, blown up economic or national impacts because everybody's able to assume that things are there? Wayne, you've already talked to some of that in aviation, right, with ADS-B, but others, what have you guys seen?
Well,
let me jump in for just a
80% of ag retailers use auto steer, and the rest of them use manual. And so almost all fertilizer and pesticides applied in the United States are applied more accurately because they have the GPS available. And so that has become a very critical element. But at least in my experience, most farmers and most agribusiness people don't think a lot about what would happen if you didn't have it anymore. That this hasn't been, they've had lots of other things to worry about, and so they haven't been necessarily thinking about that.
So James, if I'm understanding what you're saying, I should care about the reliability and the provision of those space services if I care about water quality, right? Because more pesticides applied means more pesticides running off. If I care about greenhouse gas emissions, right? Because fertilizer and other production requires inputs there, right? I mean, this is a sort of an efficiency bonus to the economy that you're describing.
Right, and it's not just the amount applied, it's also how accurately it's applied. And that's where the remote sensing comes in, so that information from remote sensing can tell a farmer where an input needs to be applied. So we know from the color of the leaves of a certain crop that this is an area where fungicide is needed, and over here is an area where you don't need fungicide because the plant disease isn't there. And so it fits into this overall idea of producing more with a smaller environmental footprint.
It's I think probably a largely untold story. Thank you for walking us through that.
I think another area that folks kind of expect 24/7 is energy. And I don't think they understand the impact that space has on energy, both from the energy generation, from electrical generation, and from pipeline systems. The GPS systems and other systems, we kind of expect that energy will be there 24/7. But if you were to lose some of the space systems, the communications, the data transfers, things like that, that could have a fairly significant impact on some of those industries.
And how would you see those impacts playing out?
They would be, in some cases, temporary. Most of the companies that I talk with and work with, they're aware of the reliance on it. And of course, it makes their jobs a heck of a lot easier. But they're also aware that pipeline systems and energy systems are targets of adversaries. And so they have contingency plans set up to be able to operate, if necessary, at a degraded level. I think a loss of GPS would probably have a pretty significant impact in terms of the timing aspect, the PNT aspect. But I think the industries themselves, as I was told by one, look, for 100+ years, we operated without anything but valves and people turning valves.
Yeah.
Now, can they go back to that? For an extremely limited period of time, they probably could. But our systems now are based so heavily on data from space systems and from other systems that we would have to figure out some alternative solutions.
My guess is they had a lot more people trained and ready to turn valves back when they had people turning valves, and
It was a little bit easier back then.
Yeah. Frank, let me turn to you and SDA. One of the SDA is predominantly looking at fielding proliferated low Earth orbit constellations, as you were talking to earlier, to provide services to military operations on land and sea. Reliability is a really important factor for military planners and certainly for operators once they're executing. How are you guys thinking about the challenges of reliability, and particularly maintaining reliability in the face of both the cyber disruption, both accidental and intentional cyber disruption?
That's a really good question and a very interesting point, and we're in the process right now starting to try to think through some of those things. Reliability has a completely different meaning in a proliferated LEO architecture. When and with SDA, our model is we're going to launch a new tranche. We call our constellations tranches, a new tranche of satellites every 2 years. And so we're going to launch our first set in 2022. We're going to launch our second set in 24. We're going to launch our third set in 26. And right this minute, we're hitting every single schedule milestone that we've set for ourselves. So we're still on track to actually put up about 30 satellites at the roughly the end of government fiscal year 22. And we're going to test those out in early 23. Reliability a lot of times depends on keeping something going for a long period of time. Our goal is that we're going to change out things on a 2-year basis. So reliability is a completely different definition. And I don't think that we've thought through, we as not just an organization, but we as a Department of Defense, we as a country have thought through really what it means to have almost a throwaway set of satellites. It's not that we are going to throw them away, but we know that in 2 years, we're going to put up another set. We're going to replenish the constellation. We're going to change the constellation. We're going to add to the constellation. So if one fails early, okay, that's fine. But we also haven't then gone the next step, which is the change management, to start helping the users understand what that means, so that they're not thinking, well, if you don't have 5 nines reliability, I can't use the system. Well, actually you can, because it's going to be there in some form always. And we haven't gotten that kind of thinking out yet. And we're still in the process of creating it.
It's a really interesting model, and I think has enormous potential. One of the things that I've noticed and is that we often tend to think about the level of reliability or the lifespan that we're achieving on a space segment of a system, and maybe don't always think as much as we should. I'm talking particularly in the national security area here. Maybe we don't think as much as we should about the downstream user's real life experience, right? To the extent that an Army unit in the field fails to pick up a comm satellite when they're looking for it, because any segment of that system of systems that enables them to do it fails, well, they're not getting the operational capability they're looking for. And it really, from their perspective, it doesn't matter that much whether that's because a widget failed on the satellite, or because a widget failed on their terminal, or because there was a software hiccup somewhere around the road, right? The bottom line is they're not getting the comms they're depending on. And at that level, I don't think we've ever fielded a system that delivers 5 nines of reliability, right? We've got components, piece parts that deliver extraordinarily high reliability. As you think through, back to you, Frank, here, as you think through what the downstream customers of the Space Development Agency are going to be looking for, how do you solve that issue of presenting to them a capability that they can rely on in a real operational sense, not just a space for space's sake sense, if that makes sense to you?
It really does, and this is a very timely question, because just yesterday we had a Warfighter Council meeting. SDA was created for the warfighter, pure and simple, and that is the reason that we exist. Dr. Derek Chenier, the director, put it what I thought was just a very, very brilliant way. Typically, program managers care about technical accomplishment. Budgeters care about cost. The only group that cares about schedule are the people that actually use whatever it is that they're buying. They need it when they need it. They want it to do whatever it is they want it to do, but they need it when they need it. And so the warfighter cares about schedule. And we were created to satisfy the warfighter's needs and get things to them in a timely manner. The best system in the world does no good whatsoever if it takes an extra 10 years to put in front of them, because now you've got problems that you're solving that are 10 years old. So yesterday, as an example, we talked to all of the combatant commands, we talked to the services, and the way that we really answer your question is we have the warfighter tied to our hips from the very beginning, and we march with them to design and field our systems. So we have a complete organization set up to integrate the warfighter, our warfighter integration plan and council that will essentially touch base with the command and with the services on a monthly basis to make sure that what we're designing is meeting their needs. But it's the minimum viable product that meets their needs, and it's available on schedule.
General Monteith, back when you and I were both working for the Air Force, the PNT community, the GPS community, was, I think, justifiably proud of how they adapted to the operational needs of soldiers, sailors, airmen in the theaters of battle, right? And really took what was, what most people might have been thinking about as a sort of static GPS constellation and turned it into something that was regularly adapting to, really help the operators in the tough situations. That was great effort at the time, and I know you took pride in the work of your team to do things like that. What's next in that regard? How do we continue? We want space to be reliable, right? We also, as space people, most of us, we want space to be even more critical because we want to see those impacts on the ground grow even more. What can we do in your mind to actually further grow those impacts by being responsive to the needs of users on the ground, whether they're military or otherwise?
That's a great question, and I think it's a little twofold. What Frank was talking about strikes a chord with me, because what it sounds like they're doing is they're shifting to their organization to move at the speed of business, not at the speed of a traditional bureaucracy, where you lose time, you lose money, you lose capability. They're also what I think is even more important than moving at the speed of business is the approach to be customer service. Frank's customer is the warfighter. It's not the builder. It's not the deployer of a product. It's the warfighter. It's the individual at the end of the spear who, like you said, I don't care that this handheld device has 5 nines behind it, or the satellite has 6 nines behind it. I don't have signal. And so I think that's critical in the Department of Defense sector. In the commercial sector, interestingly, we see some of the same things. And I would have never expected to have this role as the nation's regulator of the commercial space transportation system. That's like walking into a room with a cloud over your head. Oh my gosh, the regulator is here. So where my job becomes critical is finding that balance where we protect the public from catastrophic events in this business, but we regulate only to the extent necessary, which allows for that innovation and sets that stage for these companies to actually drive forward and try new things. And I would give you one quick example that crosses, both of these worlds. When I was at the 45th Space Wing, unfortunately, Vandenberg Air Force Base in California underwent some significant fire damage, or experienced some significant fire damage, really degrading their ability to launch rockets. And so I had my team at the time start looking, if the nation needed access to a polar orbit and Vandenberg couldn't provide it, could we do anything about it? And we actually demonstrated that we believe there was a safety case with one company, and that happened to be SpaceX. And it was because they were flying an autonomous flight safety system, again, something else that uses GPS. And so fast forward a few years, now I'm in this job, and SpaceX actually comes and wants to try this orbit. Well, once again, my career dissipation light starts to blink a little bit, going, oh my gosh, it'd be the first time we've done this in 60 years. But having my team lean forward and go figure out, ship from no because to yes if. Let's enable this industry. Let's work on the commercial side to further the commercial industry, and by default then potentially helping the Department of Defense as well. We actually demonstrated that recently with SpaceX's SOUCOM 1B mission. Absolutely worked flawlessly, worked as planned, the public was safe, and we demonstrated that we can do this. And so not only we do, the customer service part, moving at the speed of business, but now we also add in a resilience factor, which I think is very, very important when you talk critical assets.
Yeah. Thoughts from the rest of the panel on, these kind of leverage opportunities? All right. Well, let's focus in a little bit more on enhancing reliability here. As each of you thinks about sort of the end-to-end cycle of space capability, where do you see the weakest links in the areas where the industry should focus most, industry, government, regulators, otherwise, should focus most in order to allow the American people and the world to get even greater benefit out of space? I'll start with Ron, since you've got kind of the big picture on this, and then let others chime in as you see fit.
Cradle to grave, cybersecurity, space is now a contested military domain. That's been accepted. We know that adversaries have the capability and the intent to disrupt systems. We know that our cybersecurity systems has been a weak point. Even within the supply chain, we know that adversaries can, if they choose to, deliberately corrupt certain parts to potentially create systems that will malfunction. Now, have they done that? The jury's kind of out a little bit, but cybersecurity is key in terms of building it in, baking it into the design for future systems. We need to bake it in. We need to bake it into the operations before the bird goes up. And then you have the cybersecurity issues that follow post-launch. But that's not the only thing. There are a number of other things. We look at the physical security as well, from a whole variety of things, from the terrestrial assets to the spacecraft itself, to what are the things that can affect that physical security, insider threat, adversarial exterior threat, a whole variety of things. So for us, it's a cradle to grave risk assessment picture, looking at every aspect of the satellite from a terrestrial and a space asset perspective.
Frank, how about you?
Well, let me start by saying that Ron is my hero because he's absolutely correct. If you think about proliferated LEO, and it doesn't matter that SDA is building it, it doesn't matter that SpaceX is building it, or any of the other companies that are putting up their systems. When I was at Northrop, I spent a lot of years at Northrop in industry. I remember distinctly a conversation that Ron Sugar had with a group of us, and he said, or somebody asked him, what is it that keeps you up at night? And I don't know what kind of answer we all expected, but the answer was, there's 125,000 people, in those days there's 125,000 people in Northrop Grumman, and I'm afraid one of you will do something stupid. And proliferated LEO, if you think about it, is kind of like a company where you've got all of these people sitting in front of computers, and you're petrified that one of them is going to click the link. And the way that these systems are designed and the way that they're intended to work is that they talk to each other and they don't talk to the ground, because that's how you drive the latency down. That's how you move the data. That's how you get things done. And cyber is probably our biggest fear, because if something happens, and it doesn't matter that it's a government system, it can be a SpaceX system, it can be somebody else's system, because ideally SDA is going to take advantage of the commercial systems out there in those instances where it makes sense. So we're not trying to build and launch everything. We're trying to work with mission partners. But the minute that you do that, you've got all these links that can be clicked. So I completely applaud Ron, and please, work a little faster and help us out, because that's exactly what's going to make a difference.
Thank you very much. Wayne, do you want to jump in?
Yeah, the thing that keeps me up at night is similar, and that's the kinetic part of this, and that's things going bump in the night up there, and polluting certain orbits or even the ability to get to orbit. And sometimes, well, it always happens so far accidentally. And I was in the wing doing space situational awareness when Cosmos 2251 and Iridium 33 collided. And we went from 2 objects to hundreds of objects within a couple of orbits. I worry about the same thing today, particularly with the proliferated LEO concept and the amount of time that objects that are no longer operational are allowed to stay on orbit. Because we're getting congested up there. It's not just the contested part, it's the congested part. And when you look at 12, 15,000 satellites or more, 20,000 satellites in low Earth orbit, you need to be worried about that. You need to worry about the Kessler effect when these things start bumping into each other and create an opportunity for an exponential growth in debris. And in my line of work, doing the space transportation, the way I would describe it to folks is an orbit is like the beltway around the National Capital Region. So think 395 or 495. And my job is to get you on and off the beltway. So the on-ramps and the off-ramps. And do it safely, because if I put you onto the on-ramp at the wrong time and you collide with something, now all of a sudden the beltway stops moving. And we don't want that. And I can tell you, we recently had an operation where proximate to launch, so less than a week from launch, we had to go to an operator and said, we're going to have to change your injection profile, how you're getting into orbit, because we think that you may run too close to another object. And so we're already seeing this, and with these proliferated LEOs, what I'm starting to envision it at is like a screen door. And we're going to have to figure out how you get through that screen door without hitting the edges, almost like the game we played as a kid, Operation. You don't want the buzzer to go off and the nose to light up, and that's what it is when you're getting too close to another satellite. So this is becoming a real problem that if we don't get our arms around, will degrade our ability to take full advantage of this critical infrastructure that we call space.
Mm-hmm. And your team's really got to make sure on that launch collision avoidance that we are applying good solid discipline. You've raised a great topic there, Wayne, and one that we absolutely have to be conscious about. I'd add just one point to what you said, which is not only is it an increasingly crowded domain and a contested domain, but it's also a democratized domain, meaning we've got many more actors, right? And so while it used to be that if the Air Force said, this is the policy, and if the FAA said this is the policy, and if their Soviet equivalents said this is the policy, well, that was it. Now we've got quite a lot of launching states. We've got dozens, half a hundred plus operating states. And it is not a simple matter of just signing a document, right? We've got to actually lead a diverse community, by the way, all by treaty, all of whom have equal right to be there, right? I mean, the fact that Starlink is in a particular orbit doesn't give Starlink the universal right to that orbit. And, the just recently announced massive P-LEO constellation from China legally has every bit as much right to go there. Now, it might be an incredibly dumb operational decision to go there, but we can't bank on wisdom triumphing over other priorities. James, let me turn to you to kind of close us out on this, again, representing the end user, and as you know, it's getting on towards dinner time here, we're all especially conscious of the community that you support.
And farmers and agribusiness people worry about cybersecurity. They worry about the reliability of GPS, but they're not, you know, directly involved in creating any of that infrastructure. If we think about bottlenecks or things that could be enhanced that would really move agriculture ahead, then if we think about satellites and resolution of imagery. So if you think about what you can do with, say, 10-meter resolution imagery, basically you can use that in July and August when you have a very good crop cover. But earlier in the season, when the plants are really small, you're going to need much greater resolution to be of any use. And so, and then reliability. So a few years ago, I did a workshop for NASA, and we asked users, agricultural users of satellite data, did they want multispectral data, hyperspectral data, or did they want the images more often? And the overwhelming answer was they wanted them more often, because in order to get a reliable image once a week, you basically had to have an image every day, you know, because of clouds and so on and so forth. So it's issues like that that would move the agricultural sector ahead much more rapidly. And I hope those get taken into account as all these plans are being made.
So the farmer's perspective on cloud cover is shifting. It's from a sign of moisture coming to a sign of data flow interrupted. I had not thought about that.
Yeah.
All right. Well, gentlemen, let me say again, thank you for your time here. I think this has been an interesting conversation and one that's touched on many facets of what is clearly an increasingly critical part of human life and a vital contributor to a whole host of infrastructures. So appreciate you joining me to explore the value of space and to help us to kick off this Space ISAC conversation. Hope you all have a great rest of your day, and look forward to conversation with the audience.
Thank you for the opportunity.
Thank you.